It began, as so many discoveries do, with a dot. A single pixel moving across a sea of black on the screens of the Atlas Survey Telescope in Chile. At first, it looked like nothing, a flicker, a speck of light between background stars. But by the time astronomers realized what they were seeing, it had already crossed the border between ordinary and extraordinary. That faint dot was 3I Atlas, the third known interstellar visitor ever detected by humanity. Unlike any comet before it, it didn't belong to our sun. It came from the deep cold between the stars, a relic older than the solar system itself. By the summer of 2025, telescopes across both hemispheres turned to watch it. From the Atacama Desert to the Hawaiian peaks, from Hubble to James Webb, from NASA's SphereX to the European Southern Observatory, the entire scientific world was watching one traveler, a messenger from another star. And what they saw changed everything. In July 2025, the Atlas telescope captured the first confirmed images. Small, faint, but moving. Its speed was breathtaking, its trajectory clear. This object was not bound by the sun's gravity. It was passing through. Astronomers had seen this only twice before, Oumuamua in 2017 and Borisov in 2019. Now, 3I Atlas had joined that cosmic lineage, but as it approached, the mystery deepened. The Very Large Telescope in Chile caught its movement across the night sky, not as a steady glow, but as a pulse, a rhythm of light. Then came the first surprise. 3I Atlas's brightness flared. The light curve rose not smoothly, but like a heartbeat, fast, sudden, alive. And yet, there was no visible tail. Every comet in history develops one when sunlight vaporizes its ice, but this was different. The Gemini North Telescope revealed a compact halo, sharply defined, glowing blue, a hue rarely seen in natural comets. The polarization pattern of its light looked more like metal than dust. NASA's SphereX confirmed it. The object was rich in carbon dioxide, but its surface reflected light in a way that implied structure, layers, perhaps plates. When James Webb pointed its infrared eyes toward it, the data made scientists fall silent. Spectral lines appeared and vanished within seconds, too fast for known ICEs, too deliberate for randomness. By late August, the Gemini South Observatory delivered the clearest image yet, a deep space composition, through red, green, blue, and ultraviolet filters. There it was, gliding across a field of stars, its core glowing like an ember. Its tail had grown, long, thin, yet unnaturally straight, aligned not by solar wind, but seemingly by intent. NASA's Goddard Space Flight Center analysts noticed something else. The object wasn't following its predicted orbit. It had shifted, just a few arcseconds, but enough to raise eyebrows. A mountain-sized body nudged sideways by an invisible hand. If the motion came from outgassing, the comet should have lost billions of tons of material. But the halo stayed small and clean. Instead of fading, its brightness increased. Something inside 3I Atlas was changing. Then, the ExoMars Trace gas orbiter, orbiting Mars, caught sight of it on October 3, 2025. Even from another planet, the comet blazed bright against the Martian sky. Its motion was erratic, the glow pulsing faster, as if responding to the sun's heat, or something else entirely. Astronomers began to whisper comparisons to Oumuamua, that other enigmatic visitor whose acceleration had defied physics. But 3I Atlas seemed even stranger. Its spectral color shifted toward ultraviolet, its composition rich in water, ice, carbon monoxide, and something resembling nickel alloys. Nickel, common in spacecraft construction. Could this be a coincidence? Or had humanity stumbled upon something more than ice and rock? Harvard astrophysicist Avi Loeb publicly urged NASA to release all images without delay.
Transparency, he said, is the foundation of truth. And if nature is showing us something new, we must face it with open eyes. Congresswoman Anna Paulina Luna echoed the call, pressing NASA to share the latest Webb and Gemini data. The world's media followed. NASA's Atlas signal trended globally. Inside NASA, scientists worked through the shutdown, keeping the data flowing. Encrypted transmissions arrived hourly. Brightness spikes, velocity shifts, infrared anomalies. Each night brought new questions. What if the acceleration wasn't random? What if it was a controlled response, an ancient system waking after billions of years? When Voyager 1 left our solar system decades ago, it became our first interstellar artifact, carrying a message in a bottle to whoever might find it. Now, many asked, could 3I Atlas be someone else's Voyager? A relic, drifting for eons, reactivated by the touch of our sun. It's easy to dismiss such ideas as fantasy, but science advances by asking the unthinkable. Because, as Loeb once said, when theory breaks against observation, it's theory that must yield. And observation keeps breaking everything we thought we knew. 3I Atlas rotates slower than any comet its size. Its orbit is nearly planar with Earth's, impossibly aligned. Its tail bends toward the sun, not away. And every time it passes through a different wavelength band, the reflected light pulses, 12 seconds apart, in a perfect golden ratio rhythm. Coincidence or communication? By November, the comet had slipped behind the sun. Most telescopes lost sight, but instruments aboard ESA's ExoMars orbiter kept tracking. They confirmed an increase in its tail's luminosity, as if the object had flared again while hidden from Earth. Then, silence, until just days later, 3I Atlas re-emerged, brighter, more active, and now accelerating away from the sun faster than any model predicted. Its trajectory showed a slight deviation toward Jupiter, right where ESA's JUICE spacecraft is headed. The European Space Agency announced plans to attempt a remote image of the comet as it passes near the gas giant in early 2026. If successful, it would mark humanity's last clear glimpse of this visitor before it vanishes forever into interstellar night. But even as it leaves, 3I Atlas is rewriting textbooks. Its isotopic ratios reveal origins older than our sun, 7 billion years, perhaps formed in the quiet outskirts of a dim red dwarf system. Its water carries a different signature, hinting that life's ingredients might be common across the stars. For planetary scientists, it's a dream come true, a direct sample of another solar system's chemistry. And yet, for many, it feels like something more. A message wrapped in ice and dust, whispering across the void. A reminder that we are not just observers in the galaxy, we are participants. As it fades beyond our reach, NASA's Sentinel program is already being designed, a global array of robotic telescopes ready to catch the next interstellar visitor. The Vera Rubin Observatory will scan the entire sky every 2 nights, ensuring that discoveries like 3I Atlas won't slip by unnoticed again. We are building an era where first contact, whether with physics or with intelligence, may no longer be science fiction. Perhaps 3I Atlas was just a rock. Perhaps it was something more. But either way, it forced us to look outward and inward. It united engineers, politicians, and dreamers in wonder. And somewhere, out there, in the endless dark, that faint blue light continues its journey. Maybe not escaping, maybe simply going home.